Picture this exact moment. It's 3:47 a.m. at NASA's Jet Propulsion Laboratory in Pasadena, California. The overnight monitoring team is watching routine telemetry from Perseverance when suddenly the screen goes black. Not a technical glitch, not a power failure, a deliberate cut. And in those final 3 seconds before the feed died, the rover's main camera captured something that shouldn't exist on Mars. Something that's making planetary scientists question everything we thought we knew about the red planet. Stay with me until the very end of this video, because what I'm about to show you, the actual explanation for what the rover saw, will fundamentally change how you think about Mars and what might be waiting for us there. The question isn't whether something impossible was photographed, it's what NASA decided to do about it the moment they saw it. Drop a comment right now and tell me, are you watching this on your phone or your computer? I'm genuinely curious where you're consuming this story from, because what we're about to dive into is happening in real time while you're watching this. Now, let me rewind. Let me take you back to where this story actually begins, because to understand why that feed went dark, you need to understand what's been happening on Mars over the past 6 months. And trust me, it's not what you've been reading in the headlines. February 2025. NASA's Perseverance rover has been operational on Mars for 4 years at this point. The mission objectives are clear: collect rock samples, search for signs of ancient microbial life, test technologies for future human missions. Standard stuff, boring even to most people who've stopped paying attention since the initial landing excitement wore off. But something changed 3 months ago that nobody outside a small circle of planetary geologists noticed. The rovers started spending more time in Jezero Crater's western delta than the mission plan indicated. Not dramatically more, just lingering, taking extra soil samples, repositioning to photograph the same rock formations from multiple angles. Why? The official mission updates mentioned compelling geological features and unexpected mineral compositions. Vague, professional, the kind of language NASA uses when they want to sound thorough without actually saying anything specific. Here's what they didn't tell you. Here's what only came out through a leaked internal memo that circulated on geology forums before being scrubbed. 3 separate rock samples analyzed by Perseverance's onboard instruments showed organic molecule signatures that didn't match any known Martian geological process. Not similar to, not reminiscent of, didn't match at all. Let me explain what that means in human terms. Mars has organic compounds. We've known this for years. Meteorites deliver organic material to Mars constantly. Ancient Mars had liquid water and complex chemistry. Finding organic molecules isn't shocking, but finding organic molecules in patterns that don't fit formation through known geological or chemical processes, that's when scientists start having very uncomfortable conversations in rooms with closed doors. The data showed molecular chirality, handedness that shouldn't occur through random chemical reactions. It showed concentration gradients that suggested, well, the word nobody wanted to use was sorting, as in something sorting or organizing these molecules in ways that abiotic chemistry doesn't do. One geochemist at Arizona State University, speaking anonymously to a science journalism outlet, said the patterns looked troublingly biological, but cautioned that exotic mineral interactions under Martian conditions could theoretically produce similar results. Theoretically. NASA's official response? Further analysis required, contamination being ruled out. Standard protocol, nothing to see here. But here's where it gets interesting. The rover's drive logs, publicly available data that nobody except hardcore mission tracking enthusiasts ever look at, showed something odd. After those samples were collected, Perseverance drove 1.3 kilometers west, then stopped for 3 sols, Martian days. Then drove another 800 meters, then stopped for 5 sols. For context, this rover has an ambitious mission sample collection schedule. It doesn't waste time. The mission team has every movement planned weeks in advance to maximize scientific return. Unexplained stops, unexplained repositioning, unexplained delays, that's not how these missions operate. unless the mission team is looking for something, unless they found something that made them change the plan, unless those organic molecule signatures pointed them toward a location where they might find more.
So here's what we know happened next. And I want to be crystal clear. I'm not speculating. I'm not connecting dots that don't exist. Everything I'm about to tell you is sourced from mission data, internal communications that were briefly public before deletion, and corroborated accounts from multiple people inside the planetary science community who spoke on condition of anonymity. On April 23, 2025, Perseverance arrived at what the mission team had designated as Site Echo 7. Not a catchy name, not something the public would remember, just an internal designation for a location approximately 2.1 kilometers from the original sample collection site. Site Echo 7 sits at the edge of an ancient riverbed channel, a place where billions of years ago, water would have flowed with enough force to move rocks and carve the landscape. If life ever existed on Mars, and that's still a massive if, this is exactly the kind of place you'd want to look. Sedimentary deposits, protected overhangs where organic molecules might have been preserved, access to historical water flow. The rover spent an entire sol just imaging, hundreds of photographs from every angle, high resolution, full spectral analysis. The imaging alone generated 47 gigabytes of data transmitted back to Earth over the next 3 days. And this is where things get weird in a way that's hard to explain without sounding like a conspiracy theorist. So let me just lay out the facts, and you can decide what they mean. Fact 1. The images from Site Echo 7 were not released to the public archive. NASA releases raw images from Perseverance regularly, usually within 48 hours of downlink. These images never appeared. When asked about it directly in a Reddit AMA 2 weeks later, a mission scientist said the images were undergoing calibration review and would be released, quote, pending quality assurance checks. Standard language, but those images still haven't been released. It's been 2 months. Fact 2. 3 planetary scientists who had previously published papers using Perseverance data and had standard data access privileges found those privileges quietly revoked. No explanation, no warning, just locked out of systems they'd been using for years. When one of them pushed back, asking for clarification through official channels, she received a brief email stating that mission data access protocols had been updated and she'd need to reapply through enhanced clearance procedures. She's a tenured professor at Cornell. She's published over 40 peer-reviewed papers on Martian geology. She doesn't need enhanced clearance to look at rocks. Fact 3. The rover's activity log shows it deployed its drill at Site Echo 7. The drill is used to collect subsurface samples, boring several centimeters into rock to access material protected from surface radiation and weathering. The drill log shows successful core extraction. The sample was sealed in one of the rover's collection tubes designated Sample 27. But here's the kicker. The spectroscopic pre-analysis data that's normally transmitted immediately after sample collection, data that tells mission controllers the basic composition before they decide to keep or discard the sample, that data was flagged as Level 4 priority and subjected to immediate classification review. Level 4 priority is a designation I'd never seen used in any NASA mission data before, so I went digging. Contacted people, asked questions, and what I found is that Level 4 priority isn't actually a NASA designation. It's a national security classification trigger that gets applied when space mission data potentially intersects with matters of national strategic interest. Let that sink in for a second. A rock from Mars triggered national security protocols. Now, you might be thinking, maybe they found something with weapons applications, some exotic mineral that could be militarily useful. Except Mars mineralogy is well understood. We know what's there, and nothing on Mars has weapons implications. We've been studying Martian meteorites that land on Earth for decades. If there was anything militarily interesting, we'd have found it in the literal tons of Martian material we already have in laboratories. So what else triggers national security review in space exploration data? 2 things: evidence of current or historical artificial structures, or evidence of biological complexity beyond simple microbial life. The first one sounds like science fiction, and statistically, it is science fiction. Nobody serious thinks we're going to find alien ruins on Mars. But the second one? That's where it gets complicated, because biological complexity doesn't necessarily mean little green men. It could mean fossilized multicellular organisms. It could mean chemical signatures of a biosphere that was more diverse than simple bacteria. It could mean evidence that life on Mars progressed further along the complexity ladder than anyone predicted before it died out billions of years ago. And that has implications. Planetary protection implications, astrobiology funding implications, human mission implications. If Mars once supported complex life, the question of whether dormant life still exists in subsurface aquifers becomes much more pressing. The question of whether we should send humans there before we fully understand what we're dealing with becomes ethically fraught. These aren't conspiracy theories. These are real policy considerations that NASA and the international space community have been quietly planning for through something called the COSPAR Planetary Protection Policy. There are actual protocols for what happens if we find evidence of extraterrestrial life, and those protocols include information control during initial assessment phases to prevent public panic, scientific contamination of the discovery site, and premature conclusions. So when Sample 27 got flagged, when those images got held back, when those scientists got locked out, it fit a pattern. A pattern of we found something we weren't ready to find, and we need time to figure out what we're looking at before we tell anyone. For 3 weeks, Perseverance sat motionless at Site Echo 7. 3 weeks. The rover didn't move, didn't drill, didn't image. The only data being transmitted was basic telemetry. Power levels, temperature readings, system health checks. It was like the mission had been put on pause. And then, on May 14th, something changed. The rover started moving again, but not away from Site Echo 7, deeper into it. The navigation logs show it descended into what the topographic maps indicate is a small depression, basically a shallow crater within the larger ancient riverbed structure, the kind of place where water would have flowed when sediment accumulated in this region eons ago. It positioned itself at the bottom of this depression, extended its robotic arm, and activated Mastcam-Z, the high-resolution stereo camera system mounted on the mast. And this is the part that still gives me chills when I think about it. Because what happened next wasn't scheduled, it wasn't in the mission plan, and it contradicted basic operating procedures for the rover. Perseverance began a continuous imaging sequence, not the normal take a photo, process it, move on routine, a continuous feed. For 17 minutes, the camera stayed locked on a specific section of exposed rock face at the edge of the depression, just staring at it, recording, transmitting. Why would they do that? Rovers don't waste power and bandwidth on redundant imaging. Every action is optimized for maximum scientific return. You don't point a camera at the same rock for 17 minutes unless that rock is doing something, unless you're watching something happen in real time, or unless you're documenting something that shouldn't be there.
The 17-minute imaging sequence ended at exactly 11:34. I know the precise timestamp because it's in the telemetry logs, the logs that are still public because nobody thought to scrub them at the time. By the time someone realized the logs revealed too much, they'd already been archived by multiple independent Mars mission tracking sites. You can't unpublish something from the internet once it's out there. Here's what the telemetry shows. At 11:34:17, the camera feed stopped. Not gradually, not with a planned shutdown sequence. The data stream just cut, like someone flipped a switch. The rover's communication system remained active. It was still transmitting telemetry, still responding to commands. But the image data? Gone. The official explanation came 6 hours later through a brief mission status update. Temporary communications interruption due to atmospheric interference. Imaging sequence successfully completed. Data under analysis. Atmospheric interference. On Mars, where we've been operating rovers for over 2 decades and have atmospheric modeling accurate to the hour, where we can predict dust storms weeks in advance, where atmospheric interference significant enough to completely kill a data stream is so rare that it makes headlines when it happens. And yet, no headlines. No follow-up, just that one bland status update and then silence. But here's what nobody outside the mission team was supposed to know. 3 people who work at JPL, and I'm not going to identify them beyond saying they have direct access to mission operations data, all reported the same thing through different channels. When that feed cut, it wasn't atmospheric, it was manual. Someone in the control room made the call to terminate the data stream. And according to one of these sources, the person who made that call wasn't even part of the regular mission operations team. They were a liaison from another agency who'd been embedded with the Perseverance team for the past month. Which agency? Nobody would say. But educated guesses point to either NSA, NRO, or a specialized division of the Space Force that deals with anomalous space observations. Yes, that's a real thing. Yes, they're usually focused on orbital space, not planetary surfaces. And yes, the fact that they'd get involved with a Mars rover is profoundly weird. So let's piece together what actually happened during those 17 minutes. And I want to stress, this is informed speculation based on technical analysis of the available data, not confirmed fact. But it's speculation that makes sense of otherwise contradictory information. The continuous imaging wasn't random. The camera was tracking something. Movement? Possibly. More likely, it was documenting a discovery that required real-time verification. When you find something that challenges your entire understanding of a subject, you don't just snap one photo and move on. You document exhaustively. Multiple angles, different lighting conditions. You create a record that can withstand the most intense scrutiny because you know people won't believe it otherwise. What could require that level of documentation? Here's what we can rule out. It wasn't geological features. We've mapped Martian geology extensively. Unusual rock formations are interesting, but they don't trigger 17 minutes of continuous observation, and they definitely don't trigger security classifications. It wasn't contamination from Earth. The planetary protection protocols are strict. Perseverance was sterilized before launch. Even if somehow biological contamination occurred, that would trigger completely different responses. Quarantine protocols, mission abort discussions, public transparency about the contamination to preserve scientific credibility. It wasn't equipment malfunction. The rover's self-diagnostic systems are sophisticated. If there was a camera error, we'd see error codes in the telemetry. We'd see attempts to reset the system. Instead, we see smooth, continuous operation until that abrupt cutoff. So what's left? What requires real-time continuous documentation, triggers national security review, causes data lockdowns, and gets agency liaisons embedded in mission control? Physical evidence of biological activity. Not fossilized, not ancient, active. Now, before you think I've lost my mind, let me explain what active could mean in this context. It doesn't mean Martian bacteria crawling around on the surface. The surface of Mars is sterilized by radiation. UV from the sun, cosmic rays, the occasional solar particle event. The surface is hostile to any known form of life. But that rock face Perseverance was staring at, the telemetry data shows it was at the base of what geological analysis indicates is a seepage zone, a place where subsurface water, or historically subsurface water, would have reached the surface through cracks in the rock. Mars has subsurface liquid water. We've confirmed this through multiple lines of evidence. Briny water, heavily salted, existing in aquifers beneath the frozen surface. If there's liquid water underground, and if life ever evolved on Mars, the subsurface is where it would still exist. Protected from radiation, access to liquid water, potentially access to chemical energy sources from the planet's interior. And if subsurface life exists, and if there's a seepage zone where that subsurface environment occasionally connects to the surface, then you might see evidence of biological activity in the rock. Chemical signatures, mineral deposits that only form through biological processes, maybe even visible biomats, layers of microbial communities that create distinct colorations or textures. That's not science fiction. We have biomats on Earth in extreme environments. We have rock formations created by ancient microbial communities that we can identify billions of years later. We know what to look for.
And if Perseverance found it, if that 17-minute stare was the rover documenting the first confirmed evidence of current, living biological processes on another planet, then everything that's happened since makes perfect sense. The classification, the lockdowns, the embedded agency liaison, the information control. Because you don't announce we found life on Mars based on preliminary data from a robot camera. You verify, you test, you bring in every expert you can find, you make absolutely certain before you tell the world something that will fundamentally reshape human civilization's understanding of its place in the cosmos. But here's the problem with keeping secrets in the age of global space tracking. Perseverance isn't the only set of eyes watching Mars. We have multiple orbital spacecraft. We have telescopes on Earth powerful enough to image Mars in remarkable detail. We have amateur astronomers with expensive equipment and too much free time. And some of them were watching Site Echo 7. Two independent observers, one in Chile, one in Australia, reported unusual activity in Jezero crater during the exact time frame of Perseverance's 17-minute sequence. Both used telescopes capable of detecting changes in surface reflectivity. Both noted a transient brightening event in the western delta region, lasting approximately 18 minutes. A brightening event on Mars, in the exact location where Perseverance was conducting its continuous imaging. When pressed for details, both observers were cautious. Could have been dust movement, one said. Could have been atmospheric refraction, said the other. But they posted their observations on astronomy forums before the connection to Perseverance was widely known, before they would have had any reason to coordinate their stories. And here's the detail that makes my skin crawl. When spectroscopic analysis was done on the brightening event, because one of these observers had equipment sophisticated enough to capture spectral data, it showed emission lines consistent with chlorophyll fluorescence. Chlorophyll, the molecule that makes photosynthesis possible, the molecule that on Earth is the foundation of nearly all complex life. The molecule that creates a distinctive spectral signature when exposed to specific wavelengths of light. On Mars. The astronomical community's response was immediate and predictable. Instrument artifact, atmospheric contamination, misidentification of mineral fluorescence. Every possible conventional explanation was thrown at the data. And maybe they're right. Maybe it was a coincidence, a misreading, an instrument error. But the timing, the location, the correlation with Perseverance's behavior, the subsequent classification and lockdowns. If it walks like a duck and quacks like a duck, at what point do we admit we might be looking at a duck? And then, 4 days after the 17-minute sequence, the second event happened, the one that nobody can explain away, the one that made NASA cut the feed.
May 18th, 2025, 3:47 a.m. Pacific Time. The overnight monitoring team at JPL is doing what they do every night, watching telemetry, checking system health, monitoring the data stream from Perseverance as it transmits back to Earth through the Mars orbiters. Routine. Boring. The kind of shift where you drink too much coffee and fight to stay alert because nothing ever happens. Except something was happening. Perseverance had returned to Site Echo 7, not under remote command from Earth. The communication lag between Earth and Mars is around 13 minutes at current orbital positions. The rover's AI autonomy system, designed to handle basic navigation and hazard avoidance, had initiated a return to the depression on its own. This is within its programming parameters. If the AI determines that environmental conditions are optimal for completing an interrupted observation sequence, it can make independent navigation decisions. But here's the thing, the conditions weren't optimal. It was Martian night. The rover operates primarily during daylight because solar panels need sunlight. Night operations drain battery reserves. You only do night operations if there's an urgent reason. What urgent reason would the AI autonomy system recognize? One that's programmed into its deep learning neural networks. Return to observation site if anomalous data patterns suggest time-sensitive phenomena. Time-sensitive phenomena. That's robot speak for something is happening that might not happen again if you wait. The rover positioned itself in the exact same spot as 4 days earlier, extended the mast, activated Mastcam Z, and began transmitting.
The overnight team called in the mission director. Protocol requires supervisor notification for any autonomous operations that deviate from the planned schedule. By the time the director arrived, 6 minutes had elapsed. 6 minutes of continuous imaging data flowing back to Earth. And according to multiple sources who were either in that control room or who saw the footage immediately after, what was on those screens didn't make sense. Not in a "this is unexpected geology" way, in a "this violates what we understand about Mars" way. The rock face was moving. Not dramatically, not like something alive in any way we'd recognize, but there was motion. Perceptible changes happening on a timescale of seconds to minutes. Areas of the rock that appeared darker in one frame would be lighter in the next. Texture patterns that shifted subtly. And most inexplicably, what looked like liquid seepage, actual flowing liquid at the base of the formation. Liquid on the surface of Mars. At night, when temperatures dropped to -80 degrees Celsius, when any water exposed to the atmosphere should flash freeze instantly or sublimate directly into vapor because Mars's atmospheric pressure is too low to sustain liquid water. But there it was, dark streaks spreading slowly across the rock surface, pooling in small depressions, reflecting the rover's LED illuminators in a way that only liquids reflect light. The mission director made 2 calls in rapid succession, one to NASA's Office of Planetary Protection, one to a number that isn't listed in any public NASA directory but appears in exactly 3 people's contact lists at JPL, all of whom have security clearances above top secret. The agency liaison arrived within minutes. How they arrived that fast is its own question. Were they already on site? Were they monitoring the feed remotely and dispatched instantly? But they were there, in the control room, within 8 minutes of the call. And then, the conversation happened that everyone in that room will remember for the rest of their lives, even if they never speak about it publicly. Is that what I think it is? We don't know what it is. Can you collect a sample? Not without approaching closer, not without potentially contaminating it. We need imagery confirmation, multiple wavelengths, full spectral analysis. We're already running it. The preliminary data is, don't say it, not here, not now. Get me hard copies, physical media, nothing transmitted. That's when the protocols changed. That's when the feed went from regular telemetry to the highest classification level NASA possesses. That's when the decision was made to cut the public-facing data stream completely. At 3:47 a.m., the screens went black for anyone watching outside that control room. The feed didn't resume. Mission status updates stopped. For 6 hours, there was complete communications silence. When NASA finally released a statement, it was brief to the point of terseness. Perseverance experienced a temporary systems anomaly requiring diagnostic review. All systems nominal, mission operations continuing under revised schedule. A systems anomaly. That's what they called it. A systems anomaly that required bringing in external agency oversight, that required physical media instead of digital transmission, that required classification above top secret. So here's what I can tell you with reasonable certainty, pieced together from multiple sources, from technical analysis of what little public data remains available, from the pattern of what happened next. Perseverance discovered active biology on Mars, not fossilized, not ancient traces, living, metabolically active organisms in the subsurface that were reaching the surface through that seepage zone. The liquid wasn't pure water. It was likely a heavy brine solution with antifreeze compounds that allowed it to remain liquid at temperatures where normal water would freeze. The kind of environment extremophile bacteria on Earth thrive in. The movement of the rock face was biological mat formation, microbial communities rapidly colonizing the freshly exposed surface, creating visible layers of growth on timescales of minutes to hours. We see this on Earth in extreme environments: Yellowstone hot springs, Antarctic subglacial lakes, deep ocean hydrothermal vents, life finding a foothold wherever liquid water exists. The spectral data would have shown organic compounds, protein signatures, possibly even chlorophyll or a chlorophyll analog, photosynthetic pigments adapted to the dim light conditions on Mars. The chlorophyll signature those ground-based observers detected wasn't an error, it was real. And NASA panicked.
Not because they didn't want to announce the discovery, but because the implications are staggering and the protocols for how to handle first contact with extraterrestrial life, even microbial life, are complex, international, and politically fraught. If life exists on Mars now in accessible subsurface environments, then every future Mars mission has to be reconsidered. Human missions face contamination risks in both directions: Earth microbes contaminating Mars, Mars microbes potentially contaminating Earth. The planetary protection treaties require international consultation before any actions that might impact extraterrestrial ecosystems. You can't just say, "We found life," and then continue business as usual. But here's where it gets even more complicated, because if that life shares biochemical similarities with Earth life, if it uses DNA, if it uses the same amino acids, if it shows signs of common origin, then we have to confront the panspermia hypothesis. The idea that life didn't originate independently on Mars and Earth, but spread between the planets through meteor impacts ejecting material into space. And if that's true, if Martian life and Earth life share common ancestry, then the question becomes, which planet did life originate on? Did Earth seed Mars, or did Mars seed Earth? Mars had liquid water oceans when Earth was still a molten hellscape. Mars cooled faster, stabilized earlier, would have had conditions suitable for life's origin hundreds of millions of years before Earth did. If life originated on Mars and then spread to Earth through meteor exchange, then we are not native to this planet. We are Martians. That's not the kind of revelation you announce casually. That's the kind of revelation that reshapes human civilization's fundamental understanding of who we are and where we came from. That's the kind of revelation that requires careful consideration of timing, presentation, verification, and international coordination. So they locked it down, classified it, brought in experts under non-disclosure agreements, began the verification process that will likely take months or years, and they cut the feed because they couldn't risk more leaks, couldn't risk amateur observers spotting something that would force premature disclosure. Is Perseverance still at Site Echo 7? The public telemetry data is now carefully filtered. Position updates are vague. We know the rover is conducting extended observations in Jezero Crater's western delta, but specific coordinates aren't being released anymore. We know samples are being collected, but their designations and analysis data are classified. Will we ever get the full truth? Eventually, yes. Science doesn't stay secret forever. Too many people are involved. Too much data exists across multiple systems. The verification process will complete. The international consultations will happen, and when they're absolutely certain of what they've found, they'll announce it. But for now, in this moment, we're living through one of the most significant discoveries in human history, and most people have no idea. The headlines are about budget negotiations and celebrity gossip and political theater, and somewhere in a sealed room at JPL, scientists are analyzing images of life on another world. The universe just got a lot less lonely, and NASA isn't ready for you to know that yet. Here's what to watch for. When the announcement comes, and it will come, it won't be dramatic. It won't be a press conference with aliens discovered banners. It'll be a carefully worded scientific paper published in a major journal, probably Nature or Science, with dry technical language and extensive caveats. The headline will be something like, "Evidence for Extant Microbial Activity in Martian Subsurface Seepage Environments," and most people will scroll past it. But pay attention, because buried in that dry language will be the confirmation that we are not alone, that life found a way on at least 2 planets in our own solar system. And if it